That was a wonderful, captivating talk, Professor Tajima. We have a number of questions from our participants from the audience today. So, without further ado, we'll get started with some of those. So, one of the questions, what seems like a young researcher has had, is related to organic solar cells. So, in practice, for the devices your group has made, and in general, what is the maximum operating temperature for organic solar cells? And in practice, do they need any kind of cooling systems?
Organic solar cell, it depends on how to use it. So if you use it outside, or like the idea is putting this film type solar cell on the rooftop or wall of the building to get the maximum solar energy. And in that case, temperature can get very high, like I don't know, 50, maybe higher in India. It's yeah. So, but the cooling system is probably expensive to do this um, uh, to be viable for the energy as an energy source. So it's important to get the material system stable at the high temperature. So stability of the OBB photovoltaics is a major issue, and a lot of people still working on it. Yeah, it's probably the toughest part of this research uh, to be really real application.
Thank you, Professor. Another question from a young researcher is whether these findings are applicable to films that are not obtained via spin coating, because spin coating is not always feasible in a lot of laboratories, and there is
Yeah.
some literature that also says that it may not even be the best method.
Yeah, that's a good question. And yeah, of course, in principle, it should work in any solution-based coating method, like blade coating, like knife coating, yeah, spray coating, maybe. We haven't tried it, but because it's rely on the principle of the low surface energy of the surfactant, it should work similarly to the other coating methods. So spin coating, the question is right. So it's not a very good way to produce large scale production. So yeah, but I hope it's gonna work for the other coating method.
Thank you, Professor. Uh, the next question we have is related to the slide which refers to the solar cell performance of the sequential and mixed deposition approaches.
Right.
So, do the differences originate from different absorption characteristics or different electrical properties?
Okay. Optical property is similar. So by adjusting the condition, we can get a similar optical property between these two films. I would say large difference is the after absorption. So as I put it somewhere, so exciton diffusion of the diffusion of excited state of the molecule can be affected by the molecular orientation, and also the charge transport in the vertical direction is also affected by the orientation. We cannot tell which is the main factor for the enhancement of the performance, but I think that both are contributing to this. Contributing to this difference. Yeah, higher JSC and yeah, mainly higher JSC.
Thank you, Professor. The next question is that throughout your presentation, the theme of crystallinity seems to come up quite a bit. So, the question here is, how important is the crystallinity in terms of properties for these surface layers of different orientations, or even the bulk materials, and how do they affect the performance of, say, any organic electronic device, not just specifically solar cells?
Yeah, that's a good question and a tough one. High crystallinity in general is good for the charge transport, and also optical property is often better with high crystallinity. So high crystallinity is preferred, but at the same time, if you start to have a small crystal inside the film, the orientation of the each domains is very difficult to control. So I would say the best case is, of course, both high crystallinity and the orientation is the best case scenario, and that will give you the highest performance. But and the surface induced crystallization is kind of what we can do for this purpose. The first amorphous, and then you can start crystallization from the surface of the film. That would be one way to achieve this single domain high crystalline film in organic electronics in general. But we don't have an answer.
Thank you, Professor. The next question we had from is whether the annealing processes described during the processing do they affect the final orientations in any way, or is there a preferred orientation that comes through the annealing processes?
Annealing process. I don't know which part they want to know, but in general, so polymer even annealing at high temperature, it doesn't melt, right? So it's above the TG, it's kind of local motion start to happen. So orientation can be affected, but it's not. I would say it's not drastically. So for example, face-on orientation polymer case, we annealed and we observed some improvement in the orientation, but it's not much. And in the case of small molecules, it's like a fluorine case. Crystallization happens, and because small molecules move easier than polymer, so this change is really drastic compared to the polymer. So it really depends on the molecules. But I would say that polymer tend to have the small effect of annealing in terms of the crystallization and orientation in thin film.
So it looks like we are at the and almost at the end of our session. However, I'd like to request you whether if you can spare a few more minutes, as there are a lot of questions coming up from the audience. The next question we had is related to understanding the types of orientations. Are there methods other than spectroscopic ellipsometry which could help for this kind of study?
Sorry, spectroscopic ellipsometry is
to understand the types of orientations that other than spectroscopic ellipsometry, are there other methods?
Yeah, of course, a popular way for the crystalline material is the X-ray diffraction, and that is, you can detect the orientation of the crystallized part, but it's not enough because it's useless for the amorphous film, and both using the spectral ellipsometry and the X-ray diffraction, we have a very good information by combining these two. Other than that, yeah, of course, we can use other spectroscopic techniques like IR, polarized IR, but often involve the difficulty in the sample preparation. Yeah, I would say any kind of optical method with the polarizing light would be good to detect the orientation and X-ray. Yeah, I couldn't think of any other good way or accessible way. Yeah, that's probably most popular too.
Thank you, Professor. The next question is have you observed any relationship between the degree of crystallinity and the degree of orientation or tilt angles or anything like that?
Degree of crystallinity and degree of orientation in the solar cell?
Yeah, in the solar cell or even in when the surface induced crystallization occurs.
Well, I would say the orientation of the molecule at the surface is not related to the crystallinity of the film in the bulk, because it's already kind of determined by the drying process, right? So orientation of the molecules on the surface is probably doesn't change much even after summer annealing. But the orientation in the bulk can be affected by crystallization. So I say, but it need to be first amorphous before the summer annealing, and then after summer annealing, it crystallizes highly crystalline. Then probably that's the best case. So, but if it's too crystalline, crystallinity is too high, then it already crystallized inside the film after the deposition. And summer annealing doesn't affect so much. So in that case, orientation control is could be difficult. So it's I talk it very simply, but it's really complicated play between the surface energy, crystallinity of the material, and the interaction with the surface molecule and the molecule in the bulk. So yeah, it's highly dependent on the system, unfortunately. So yeah, it's hard to answer in general.
Thank you, Professor. The next question comes from one of our participants, a researcher on perovskite-based solar cells. The question is whether the findings on orientation control and how they affect the films as well as the performance of the cells, would these findings translate to research on perovskite solar cells, and can the same approaches be used for those type of devices as well?
You mean the photo application of the similar phenomenon to the perovskite solar cell?
Yes.
Yeah, we've been thinking about it. We never work on the perovskite, but yeah, I imagine that I don't know exactly how this perovskite crystal grow during the deposition, but it could be affected surface, or definitely it affected by the interface of the substrate, right? So I think it's still possible by affecting the surface property of the liquid film, and crystal orientation or crystallinity of the perovskite may be affected, but we never tried, or maybe there's similar concept out there already reported, but I don't know about the detail. Sorry.
Thank you, Professor. The one more question is about the role of the substrate. Is the choice of substrate important when it comes to any such studies? What is the role of the substrate in the performance or the observations related to surface-induced molecular orientation or even the crystallization? That
there is two interface, so both are equivalently important for this process, right? So you cannot ignore the substrate interface, but in this case, substrate doesn't affect much, like crystallization of the PCBM case doesn't affect much. We do observe the similar phenomenon when you change the substrate. When in the case of the polymer, sorry. Maybe I talk a little bit about this case. So here silicon substrate tend to have the edge on. So it's definitely affecting the orientation in the film, and it's kind of competing to each other, I guess. But if you care, take care of this interface as well, try to get this. Actually, we modify this silicon substrate with the vertically aligned oligocyclane as well. Then we can get much better vertical orientation. So yeah, both are important, definitely. And if you aim at the perfect orientation, both should be modified.
Thank you. So the last question for now is, in the interest of time, we observed that a C6 alkyl chain was used in the organic polymer. So if a higher or lower number is used, how does it affect the findings?
You mean the length of the alkyl chain?
Yeah, the length of the chain, C6 alkyl chain is used, right, in the organic polymer. So
well,
if we replace that and use something else, let's say higher or lower number,
mhm.
how would it affect the findings? Would it remain similar, or would we be seeing
Yeah.
some very different results?
Okay. Length of the RQ chain change the crystallinity of the polymers a lot. So we know that particularly this poly 3 RQ cyclone case, shorter RQ chain gives a very high crystalline material. Longer chain, you got less crystalline. So it affects the crystallinity of the material. And we did some investigation on this issue, like what happens if you change the RQ chain length, or even change the length of the surface RQ chain in the surface monolayer and the length in the bulk. What's going to happen? But we don't have clear tendency. I would imagine that if these two components are similar, it affects better than the case where we have a different structure, like a length of the RQ chain. So yeah, we intentionally try to use the similar structure between the surface monolayer and the bulk phase. And I think there is some effect, but we don't have a clear answer how much does it affect behavior. Yeah, but I think that's a good point.
Thank you, Professor. In the interest of time, although there are more questions from the audience today, we will have to conclude this Q&A session here. So if you would have any closing remarks for our audience.
Okay. Yeah. Thank you for listening to my talk. And yeah, maybe one thing I like to tell you is that my organization, my institute, RIKEN, is the largest institute in Japan, and the major player in our institute is a postdoc and also the student from other university. We don't give out a PhD degree. So if you're interested in our work or any work in RIKEN, maybe you have a chance to come to RIKEN. Yeah, I encourage you to do the research in our institute. It's a very good environment. So yeah, please consider about the getting career here. Yeah, that's all I want to say. Thank you.
So thank you, Kaushik, and thank you, Professor Tajima. I'm sure the audience has already enjoyed the session, and as it looks like from the different questions that came in, there are still raring to go, but there is always only a limit to which we can offer the questions today. So I hope you have all enjoyed the session, and hopefully, as Professor Tajima said, you would be considering RIKEN as a potential institute for your postdoctoral training. So with that, this brings us to the end of today's session. We hope that you enjoyed this broadcast. We invite you to view the edited recordings of the past events in the ACS Science Talks library. At the end of the session, you will receive a brief survey. A link of that has also been placed in the chat. Kindly share your feedback with us so that we can continue to improve and serve you better. On behalf of all of us at ACS, thank you for joining us today. We hope to see you again soon for more ACS events. Until then, stay safe and healthy.